Our next speaker is Joseph Lautenbach, and this is the summary of Joseph's research when he was a grad research assistant at the Division of Biology at Kansas State University. I know that he's gainfully employed in Michigan. I will let him tell you exactly what he does and where he does that. Good to see you again, Joseph.
See you too. Speak right into it. You guys have this helpful stand for short people, but I'm quite tall, so I prefer to stand behind the podium, so I'll try to lean in. All right. Can everybody hear me fine? All right, so as Christian mentioned, I did my work at Kansas State University, but now I'm currently employed as an assessment biologist with the Sault Ste. Marie tribe of Chippewa Indians in their Inland Fish and Wildlife Department. If you want more details about that, I'm happy to tell you what I do. So, as we've learned today, throughout the Great Plains and the Intermountain West, we've seen this loss, well, particularly in the Great Plains, we've seen this loss of fire, and it's allowed trees to become established in grasslands. And there's research that suggests that prairie can be converted to a closed canopy forest within as little as 30 years. And that might have implications for grassland species, particularly prairie chickens. And we've seen that trees alter grasslands by shifting plant communities from warm season grasses to cool season grasses. And we've also seen wildlife shift from more grassland dominant species to forest and shrubland dominant species. However, this has never been tested with prairie chickens. It's been implicated that trees are a source of habitat loss for prairie chickens, but never directly tested. So one of the goals of my research was to sort of test this on the landscape. So what exactly is the effect of tree encroachment on lesser prairie chickens? And we are interested in investigating habitat selection, space use, adult survival, nest site selection, nest survival, and then putting all those together and looking at population growth. And as you can kind of see, we're starting out at a broad landscape and then working our way down into a more narrow, so we're looking at broad scale selection and then focusing in as we go down until we get to nest site selection, where it's a very narrow area. And then after that, if trees do impact prairie chickens, what does that mean for lesser prairie chicken conservation within the Great Plains? If there is habitat loss, how much is there? Is it possible to restore habitat and maintain habitat after this sort of tree removal if it's needed? So our study site took place in south central Kansas in Kiowa and Comanche counties on private lands. This is in the easternmost portion of the lesser prairie chickens range, and it's a mixed grass prairie in this area. And there is active tree encroachment and active tree removal in the area. However, we were not able to get enough data yet to say anything about tree removal and if that's beneficial for prairie chickens. But it's in the process right now. So we captured female lesser prairie chickens on leks in the spring, and then we attached GPS and VHF transmitters, and we tracked these individuals to nests to look at nest site selection, and then we monitored these nests to determine nest survival. And then we use these GPS points and VHF points to estimate habitat selection, both using resource selection functions and resource utilization functions. And resource utilization functions were covered very well in the last talk, so I'm not going to spend much time on that. So when we just look at a general pattern of proportion available to proportion used, with black being the proportion used and orange being the proportion available, we see that prairie chickens are already using areas with really the lowest areas with tree density. And I use tree density as a metric instead of canopy coverage because the Falkowski data set is really nice, but it's not fine scale enough for the sort of response that we are seeing by lesser prairie chickens. And again, if we look at this map that we generated, with the green dots being trees and the blue dots being prairie chicken locations, we see that prairie chickens are selecting areas with the lowest tree density already. What does that look like when we do a resource selection function? with the relative probability of use being on the y-axis and tree density in trees per hectare on the x-axis, we can see that by about 4 trees per hectare, we hardly have any use by prairie chickens. And then again, when we look at this in relation to distance to nearest tree, we see that as distance to tree increases, the relative probability of use increases and levels off right around about 800 meters away from trees. And then we looked at space use. So within home range habitat selection by lesser prairie chickens in both the breeding season and the non-breeding season. And we see that there's a strong positive relationship with distance to tree in the breeding season, indicating that these prairie chickens are spending time at greater distances away from trees during the breeding season. And we also see a strong positive response in both the breeding season and non-breeding season in relation to tree density, indicating a negative response to tree density. So as tree density increases within the home range, they're spending less time at that area, in those areas. And we did not detect any any effect on survival in relation to distance to tree and tree density on adult female survival. And we also tested mortality locations in relation to distance to nearest tree, and we found that prairie chickens' mortality locations were located at greater distances from trees than would be expected at random, indicating that these birds are not really impacted by, they're not more at risk to predation in areas closer to trees because they're simply not spending time there. And then we start looking at nest site selection, where again we look at where these birds were placed their nests in relation to the proportion that was available. And again, we see a strong relationship with low tree densities in terms of nest site selection. And again, if we look at the same map with trees and nest sites, this time being the blue dots and trees still being green, we see that nest sites are located in areas with very few trees. And when we look at the resource selection function, we see that nest site selection basically disappears when tree densities are at greater than 2 trees per hectare. And we did not detect any nests in areas with greater than 2 trees per hectare. And then when we look at nest site selection in terms of distance to nearest tree, as distance to nearest tree increases, we see an increasing probability of use in terms of nest site selection. So nest site survival was not affected by tree density, distance to tree, elevation, or slope. And, but keep in mind that we did not detect any lesser prairie chicken nests in areas greater than 2 trees per hectare, so it's hard to draw any major conclusions about nest site selection being influenced. So we've kind of covered the biology of the prairie chicken, and we know now that they do avoid trees, and at a greater idea than I ever thought when I first started talking to people and looking at the data. So the next step is to look at habitat loss and habitat restoration. And one thing that we wanted to do was check for a correlation between trees and elevation, because we thought that trees might be more likely to be located in drainages, and in fact that is true. And we also wanted to compare tree density to canopy coverage, as canopy coverage is the metric used when putting this work on the ground. And we also wanted to use that classification to classify suitable habitat based on the Falkowski data set. And we classified pixels from a land cover data set based on other categories of stuff that we're looking at in our lab in order to maximize tree removal in the mixed grass prairie ecoregion in Oklahoma and Kansas. And indeed, we found that canopy coverage and tree density is correlated with an R squared value of about 0.6. In terms of looking at what the distribution of suitable habitat is within this area, we looked at this within the mixed grass prairie, and we looked at grassland composition as some grasslands are less suitable for lesser prairie chicken use. And we also looked at anthropogenic feature densities as lesser prairie chickens avoid areas with greater oil and gas infrastructure densities and road densities, etc. And then we also wanted to estimate where trees were too dense for use by lesser prairie chickens. So where are these trees greater than 2 trees per hectare? And we used the GIS layer generated by Falkowski in 2015. And where they overlapped, we considered this to be a high priority for tree removal. So what does this look like in south central Kansas and part of Oklahoma? So the light green here is the high priority for tree removal. The black is low priority for tree removal, and the dark green is the current habitat. And there's a lot of area available to that is high priority for tree removal. Just as a kind of an interesting side note, in 2016, I think it was, there was a fire called the Anderson Creek Wildfire, and it burned about 400,000 acres, and it was kind of concentrated on the eastern edge here. And it removed a lot of the trees in Barber County and Comanche County, and this might provide an interesting opportunity to go in and clean up the rest of the trees that the fire did not get. But when you look at a total if we look at a summary of that map, we look at the areas that's not habitat and areas with greater than 2 trees per hectare and current habitat, and then habitat gain through tree removal. We see that we can increase habitat by about current habitat by about 25% just by removing trees in those areas that are high priority. So removing trees from the landscape will improve habitat, hopefully. We're in the process of testing that, so we can't say that with any certainty. But initial effort should focus on areas already occupied by lesser prairie chickens, and then move into areas adjacent to those occupied areas with greater invasions to allow for future range expansions. And it's more cost effective to start with light invasions than heavy invasions, with light invasions being considered 1 to 5% canopy coverage and heavy infestations being considered greater than 15% canopy coverage. Using numbers from the NRCS in Kansas, it costs about $158 per acre to remove trees from light invasions, indicating that it's much more cost effective to start with those lighter invasions, and up over $1,000 an acre to remove heavy infestations. And when we look at this on the landscape in the high priority tree removal area, it looks like there was about 243,000 acres. And if there was all light invasion, it would cost over $38 million to remove that area. Whereas if it was a heavy invasion all the way across the landscape, which it's not, it would cost greater than $251 million. So a more likely scenario is if 33% of that area was in each category. So that's what I kind of did just as a rough cost estimate, putting 81,000 acres in each invasion category, coming up with a rough cost estimate of 127 million, almost 129 million dollars to remove these trees. So with an investment like that, what are we going to do to prevent future tree encroachment? And fire is probably the most cost-effective method to remove trees, or to keep trees off the landscape. It's much more cost-effective in that it costs approximately $21 an acre to implement a prescribed fire, rather than $150 or over $1,000 to remove trees. And prescribed fire is a tool we're testing or investigating in terms of its relationship to lesser prairie chickens. So patch burn grazing is actively being implemented on one of our study sites in south central Kansas, and based on some of the stuff that Sam presented and some of the work that my brother Jonathan's working on, it's providing the range of habitat needs for lesser prairie chickens in that they're short grass for lekking, dense grass for nesting, and forage areas for brood rearing. And with patch burn grazing, you can have all these areas in close proximity. So you can have nesting, brood rearing habitats, and lekking habitats all within a narrow area. So some of the preliminary results from that patch burn grazing study indicate that lesser prairie chickens use a variety of these time-sense fire patches during the breeding season. And most of the nests are located in these greater than 2 years post-fire habitats. And then post-breeding space use in all patches is greater in the most recently burned areas. So as time since fire increases, the probability of tree infestation will also increase. And then patch burn grazing allows for all these different things to coexist on the landscape. Just as an example, a rough calculation of what's available and what's used by lesser prairie chickens in terms of nest site selection, we see that lesser prairie chickens are selecting these areas with greater than 2 years post-fire at a greater rate than is available, indicating that they're selecting for these areas. So with that, I'd like to acknowledge my advisor and the co-authors on this paper, and my committee members and all the folks from the KWPT that assisted us through the time. Some of them are no longer with the KWP, but they provided lots of help early on. Fish and Wildlife Service, other lab members, technicians, and of course the private landowners who made this possible. Without them, none of this would have happened at all. So, thank you. Oh, and there's time for questions. Yes, Christian.
Yeah, Joseph, if you go back to your slide that had the, you can just use nest site selection. You could give us the conversion factor on trees per hectare and what that means in terms of canopy cover.
So Christian's wondering what that means in terms of trees per hectare related to percent canopy cover, and it's 1.5%. I can't remember, but Christian remembers, and so that's the answer to the question. Yes. Yeah, yep. So we did a quick analysis of the percentage of all the trees on the landscape in that area, and 75% of the trees were eastern red cedar, and then 25% were mostly deciduous, so like cottonwood. Yeah, that's actually taken on. It's not mesquite. I don't remember what kind of tree it is, but it's a deciduous tree on the property where we're working. Yes, Christian.
Joseph, are there any hints or indications as to what the post-treatment results are looking like on the ranch where you guys have been working? Is there anything you guys can share, or is it too early?
Do we have birds using that area? So the question is in some of our preliminary data, are birds using areas where we've had trees removed? And the answer to that is yes in some cases, but it's not definitive yet. However, if you talk to some of the landowners that we're working with, they've been removing trees off their property for 20 years, and they confirm that lesser prairie chickens do move into those locations. We just don't have any data to go back. If they had been collecting all this information for us, we would be able to have a full data set ready to publish, but we don't have that luxury. Yes, Bob? I think it'd be equally important. I mean, that would provide perches for a whole host of raptor species that would potentially predate, prairie chicken, maybe even better perches because they can see out. I would say it's pretty important to go through and knock those skeletons down. I would assume that, but I don't have any data to back that up.